Okay, it's Michael. Good morning, everyone. Now I'm back again, and in this chapter, this topic, we are going to discuss about the Michaelis Menten formula as well as equation and graph, right? And including the Lineweaver Burke key or Burke plot. All right. Okay. So, rate of enzyme reaction. Ini yang kita akan belajar hari ini. So now, enzyme kinetics is the investigation of the rate, okay, and how enzymes bind substrates and turn the substrates into products. Okay. Now, enzyme kinetics theory, okay, which later on changed to Michaelis Menten theory, okay, was proposed by Leonard Michaelis and Maud Menten, okay, back in 1913, which further developed by Briggs and Haldane. So this is Briggs, okay, the lead Briggs, and this is the lead Haldane, okay, and this is the lead Michaelis and the lead Menten. Okay, so Michaelis Menten, right, describe enzyme reactions in two stages. Okay, the substrate binds to the enzyme to form the enzyme substrate complex. Can you picture that? Okay, and then the enzyme catalyzes the chemical steps and releases the products. Okay, now the rate of enzyme catalyzed reaction or reaction rate, okay, is velocity, or simply say rate of reaction of an enzyme is also known as velocity. Okay, and velocity will gradually slow down depending on which concentration is the limiting factor. Okay, and when it comes to the which concentration is becoming the limiting factor, it will be either the enzyme or the substrate that will become the limiting factor. Now, the enzyme reaction, okay, ends when all the substrate forms products. Betul kan? Apparently. Now, two ways to determine enzyme reaction or reaction rate or velocity. That is, we measure the rate of formation of products, okay, or we measure the rate of disappearance of substrates. Okay, now from this two methods of measurement, okay, that determine the velocity. Okay, Michaelis and Menten came with their Michaelis Menten plot. Apparently, this is the Michaelis Menten plot, which is a graph that is plotted reaction rate against concentration of substrates. Okay, so Michaelis Menten plot is done by plotting rate of reaction or velocity against the substrate concentration. Okay, graph is a rectangular hyperbola. Okay, apakah rectangular hyperbola? Now, the rate of reaction, okay, or also known as catalysis, or also known as velocity, okay, velocity, and can be represented with capital V, right? So velocity, okay, changes with substrate concentration. Isn't that obvious? Because you plot the graph where velocity is against the concentration of substrate or substrate concentration. So the velocity will change with the substrate concentration. Now, when the substrate concentration is small, okay, velocity is linear. When the substrate concentration is small, okay, the velocity is linear. We nampak graph ni punya apa ni gradient. You can see from this graph gradient where velocity is proportional to the substrate concentration. Now, class in the exam, do not write substrate concentration like this, okay, as in square box. Now, this is being written in such a way to simplify writing to ease learning process. Okay, in the exam, please write here substrate concentration. So again, let me rephrase this sentence. Okay, when the substrate concentration is small, okay, velocity is proportional to the substrate concentration. At higher substrate concentration, kamu boleh nampak di sini ya, when the substrate concentration is being increased. So at higher substrate concentration, the velocity is independent to the substrate concentration. Boleh nampak di sini. Okay, V itu dia tidak lagi proportional dengan substrate concentration. Okay. Why? Because saturation happens. Now, saturation happens because as substrate concentration increases, more enzymes are in the substrate complex form. Okay, that's why saturation happens. Saturation of enzyme with the substrate happens actually. Okay, enzyme itu jadi tepuh dengan substrate. Semua active site pada enzyme telah penuh. Okay, telah penuh bind dengan substrate. Padahal ada banyak lagi substrate. Substrate concentration terlampau tinggi. Okay, that's why we get this curve here. Right? This curve here. Bukan di B, di sini. Daripada sini sampai sini. Okay. Di mana kita dapati V is independent to the substrate. Yang ini part B cikgu buang. I think it's a bit confusing. Saturation happens. Okay, this is in part B. Okay, ini baru betul. Okay, kelas, so sila ubah sikit di modul kamu. Okay, now from this graph, right? Notice, okay, this is vmax, maximum velocity. Nampak ah? Bahagian graph yang plateau phase ini, this is known as the vmax or maximum velocity. So vmax is the maximum rate of reaction. Isn't that obvious? From this graph, you can easily see, all right, this point of the graph, okay, is the maximum rate of reaction, okay, where the rate of reaction cannot further progress or increase, cannot further increase or progress. This is the maximum rate of reaction. So this is vmax or maximum velocity, all right, and this is km. I will talk about this later on. Okay. Now, from the Michaelis Menten plot, okay, which is this one, betul kan? Okay. Now, from this graph, from this plot, the Michaelis Menten constant, which is the Km. So Km is known as Michaelis Menten constant. Okay, in maths, even in maths, capital K is represent the graph gradient or the constant of the graph. Okay, so the same goes for Michaelis Menten plot, where Km represent the Michaelis Menten constant. Now, this Michaelis Menten constant Km, right? It is the substrate concentration when the velocity of the reaction is half maximum or half Vmax. If this is the Vmax, right, for this particular graph, if this is the Vmax, half of this Vmax will be here, right? And if we look from the graph, okay, at half Vmax or at half maximum rate of reaction, okay, this is the value of the Km, which is the value of the substrate concentration. Okay, I will talk more about later about this Km. Why? What is the significance of this Km? Maksudnya kenapa penting kamu tahu Km ini ataupun half Vmax ini? Okay, now this Km can be used to measure the affinity of enzyme towards its substrate. Meaning to say, Km indicates the efficiency of enzymes to attract substrates. Okay, so meaning to say, at higher Km, lagi besar Km ini, alright, meaning to say, the enzyme has lower affinity for the substrate. So meaning to say, there is weak binding between the enzyme and the substrate at higher Km. Okay, maksudnya Bila Km ni besar, let's say di sini lah, right? Di sini lah Km tu, okay? Higher Km. So now, how much is the half vmax? The half vmax will be very big, okay? Very big. Meaning to say, rate of reaction tu sangat besar. Untuk dapat rate of reaction sangat besar, kena increase concentration of substrate. Okay, so maksudnya enzyme tu memang has lower affinity for the substrate. But what happens if we have smaller Km? Okay, so at lower Km, okay, means the enzyme has higher affinity for the substrate. Meaning to say strong binding between the enzyme and substrate. So meaning to say at lower concentration of substrates, okay, the rate of reaction, the half maximum velocity is high. Okay, let's say ada satu graf lagi di sini macam ni. Okay, tadi senang yang inilah reaction of enzyme, reaction without enzyme. Okay, now at half Vmax, okay, for this enzyme reaction, this particular enzyme reaction, to reach this half Vmax, okay, to reach this half Vmax, okay, only this small concentration of substrate is needed. Okay, now what about this reaction? Untuk dapat half Vmax dia, tengok, kalau saya plot graph ni, sampai sini, di sini, concentration of the substrate needs to be increased, okay, to get the similar half Vmax with this enzyme. Can you see that? Okay. So class, always remember, low Km value means the enzyme has higher affinity for the substrates. Okay, now let's talk more about this Km. Okay, kinetic parameter Km, or Michaelis Menten constant. So Km is the measure of the affinity of an enzyme for its substrate. Okay, and it's generally called the Michaelis constant, Michaelis Menten constant. So Km values of enzymes range from 10 exponent -1 to 16 exponent -6 molar, right? Molar. Okay, molar means it is the substrate concentration in molar. Km is a constant, okay, for a particular set of enzymes and substrate at optimum temperature and pH. So I mean to say, in one enzymatic reaction, the temperature and pH must be set as a constant variable, okay, where it is the optimum temperature and optimum pH for that enzyme operation, for that enzyme to operate. Km is independent of the enzyme concentration. Okay, a high Km means weak binding between the enzyme and its substrate, and a low Km means strong binding, like what I mentioned earlier. Okay, now from the graph, okay, the Michaelis Menten plot velocity of the reaction is determined by the Michaelis Menten formula. Okay, this is the Michaelis Menten formula, right? From the graph with their calculation, this and that. Okay, so Michaelis Menten came up with this formula. Velocity equals to Vmax times with substrate concentration divided with the Km, okay, plus with substrate concentration. Okay, and you know Vmax means maximum velocity, and this is the substrate concentration. Teacher, do I need to memorize this formula? Yes, usually they don't give this in the exam. If they give this in the exam, then good for you. If they don't, then that's when memorizing this formula helps you. Okay, now the enzyme reactions are viewed under 3 conditions. Okay, so this is the basic formula. Now mari kita tengok 3 condition, okay, pasal enzyme reactions ini. Now when the substrate concentration is smaller than the Km, okay, remember this is the Michaelis Menten formula, right? So when the substrate concentration is smaller than Km, what happens? Okay, the substrate concentration is being abaikan. Okay, kita abaikan yang ini substrate concentration. So what happens? We get Vmax times with substrate concentration over km. Okay, over km. And then we rewrite this equation, we get this. Itu kan vmax over km, then darab dengan S, substrate concentration. Okay. Then this can be further, okay, so because vmax over km, kita dapat itu graph punya gradient. Betul kan? Which is a constant. So, ini vmax over km ni darab dengan substrate concentration ditulis semula sebagai K times with substrate concentration. Okay. Now, second condition, when the substrate concentration is larger than km pula. Okay, bila yang ini lebih besar daripada km. So, what happens? Okay. V, okay, from this formula, yang km ini diabaikan. Km ni pula diabaikan. So, kita boleh tulis balik formula ni. We can rewrite this formula as Vmax times with substrate concentration over substrate concentration. So, we cancel off these two. We get Vmax. So, velocity equals to maximum velocity. Right? This is when the substrate concentration is larger than the km. So, the third environment, all right, third condition is when the substrate concentration is equal to the km, right? Bila yang ini sama dengan km, so what happens? Velocity equals to Vmax times with substrate concentration sama yang km ini kita ganti dengan substrate concentration. So, substrate concentration plus substrate concentration, right? So, 1 plus 1 we get 2, so 2s. So Vmax times with s over 2s. Then this can be rewrite as Vmax over 2. Sebab ini kita cancel, potong ni 2, jadi Vmax over 2. Right? So kita akan dapat yang ini. So teacher, do I need to memorize this? You can memorize better. Kalau tidak pun it's okay. Usually in the question dia akan bagi value, right? Value yang substrate concentration semua ni, okay, dia besar kah, dia kecil kan, dia akan bagi. So kamu hanya fill in saja ke dalam formula ini, just fill in. Alright, eventually kamu akan dapat begini juga. Tapi kalau dalam soalan essay, right, the essay dia suruh kamu terangkan formula ini dalam keadaan-keadaan yang 3 condition tadi, so you have to memorize this. Right? Okay. Now, the rate of enzyme reaction or velocity, okay, depends on the concentration of the enzyme substrate complex. Okay, the rate of enzyme reaction or velocity depends on the concentration of the enzyme substrate complex. So the Michaelis Menten formula can be rewrite as V equals to K2 times with enzyme substrate complex concentration. Because you know already enzyme and enzyme bind with substrate, we will get enzyme substrate complex, right? And from enzyme substrate complex, we will get enzyme and products. Okay, there is a constant here that involved in between these reactions. From on the formation of the enzyme substrate complex, we will have K1, right? But the reversible process of enzyme substrate complex to the enzyme and substrate, we have K negative 1. Okay, because they are reversed. Now, from enzyme substrate complex to the formation of enzyme products, we have K2. Okay, K2. So now, somehow based on this equation as well as Michaelis Menten formula, they came out with, okay, V equals to K2 times with enzyme substrate complex concentration. Okay, now to obtain the Michaelis Menten constant, okay, Km, few assumptions are made. Okay, first, at the maximum velocity or Vmax of the enzyme, all the active sites of the enzymes are saturated with substrate. Okay, all the active sites of the enzyme are saturated with the substrates, and the number of enzyme substrate complex must be equivalent to the original total amount of the enzyme. Maksudnya, let's say kamu ada 100 enzyme. Okay, initially ada 100 enzyme. So formation of enzyme substrate complex pun mesti ada 100. Sebab hanya ada 100 enzyme. So maksimum ada enzyme substrate complex mestilah 100, kan? Okay. Okay. The second assumption is, alright, the concentration of the free substrate is equivalent to the concentration of the total substrates. And then the third assumption is reverse reaction, right, of enzyme and product is ignored. Yalah, kita pun tahu kan, enzyme dengan produk ni is irreversible. Dia boleh menjadi enzyme dan substrate balik. Tidak boleh. So the reverse reaction of enzyme and product is ignored. Okay, and then the rate of formation of enzyme substrate complex is equivalent to the rate of breakdown of the enzyme and substrates. Okay, and the last assumption, the total number of active sites remains constant. Okay, kalau ada 100 enzyme, okay, mesti ada dalam contohnya lah 100 active sites ataupun 200 active sites, dan that value doesn't change. Tidak boleh lah ada 100 enzyme, okay, sepatutnya ada 200 active site, tiba-tiba ada 300 active site. Tidak boleh lah macam tu. Okay, so from there, right, they came up with this Michaelis Menten equation. Okay, so kita sudah belajar Michaelis Menten plot, Michaelis Menten formula, and then Michaelis apa lagi yang ini lagi, apa ini, velocity, okay, equals to K2 times with enzyme substrate complex concentration. Okay, and then sekarang lagi Michaelis Menten equation, which is enzyme substrate concentration equals to enzyme concentration times with substrate concentration over K exponent negative 1, okay, sorry, K negative 1 plus with K2, okay, divided over K1, okay, K1 ni satu ni, K1. Okay, so K1 is the rate formation of enzyme substrates. Okay, betul kan? Rate formation of enzyme substrate. K2 is the rate formation of product, and then K negative 1 is the rate dissociate of enzyme substrate complex. Okay. Hence, rate of reaction, we have V equals to K2 times with enzyme substrate concentration. Okay, like what I have mentioned in the point number 7. And then, right, rate formation of enzyme substrate, okay, is equivalent to the rate breakdown of enzyme substrate. Betul kan? Like what I've mentioned earlier. Okay, so sekarang nak buktikan macam mana dapat equation ini. So K1, okay, times with enzyme concentration times with substrate concentration equals to, okay, K negative 1 plus K2 times with enzyme substrate complex concentration. Alright, so daripada sini, okay, kita akan dapat equation yang ini. Okay, how it's not in your syllabus, tidak perlu terangkan macam mana. Okay, kamu hanya perlu memorize yang ini. Okay, so that's about Michaelis Menten. Okay, now let's continue with Lineweaver Burke plot. Okay, or this plot also known as double reciprocal plot. Okay, now this Lineweaver Burke plot is used to determine the value of the Km and Vmax. Okay, and this Lineweaver Burke plot is obtained by plotting the reciprocal, okay, of velocity against the reciprocal of substrate concentration. Okay, kalau kita cakap reciprocal of substrate concentration, means to say it is 1 over substrate concentration. Kalau reciprocal of velocity, so that will be 1 over V. Okay, so the graph gradient will give you Km over Vmax. Okay, so now from this Lineweaver Burke plot, okay, now we will get 1 over V equals to Km plus substrate concentration over Vmax times with substrate concentration. This is the modification from the Michaelis Menten formula. Okay, di mana dalam Michaelis Menten formula, if you recall, it is V of velocity equals to vmax times with substrate concentration over km plus substrate concentration. So kalau reciprocal, yang ini pun dia jadi reciprocal, terbalik. Okay, so 1 over V, yang ini kita rewrite, okay, km over V max sini times with 1 over substrate concentration, okay, plus with substrate concentration divided by Vmax times with substrate concentration. Betul kan? Ini kita asingkan sebagai satu. Yang ini, kenapa mouse ni asingkan, dan ini pula diasingkan begini. Alright, diasingkan begini. Okay. So kita akan dapat daripada sini, okay, yang dua ni kita boleh potong, yang ini tidak boleh potong, tidak boleh ringkas. You cannot further simplify this, so can be rewrite as the same as it is, which is km over vmax times with 1 over substrate concentration plus with, dipotong-potong jadi 1 over vmax. And this equation is very similar to the y equals to ax plus c. Okay, ataupun y sama dengan mx plus c, di mana a ini ialah kecurunan graf, okay, dan c ini ialah pintasan paksi y. Betul kan? Alright. So now to get the value of km from this formula, the value of this km, okay, if you recall, this km is yang a ini, kecurunan ini. So kita assume 1 over v ialah kosong, ataupun y sama dengan kosong. Ada pelajaran dalam maths form 5 tu, yang pintasan tu. Kalau macam ni kita mau dapat ni ialah kita assume y itu sama dengan kosong. Kalau yang ini pula kita mau cari pintasan pada paksi, kalau kita mau cari pintasan pada paksi x, kita assume y dengan kosong. Kalau kita mau cari pintasan paksi y, kita assume x sama dengan kosong. Okay, so kita isi value ni y dengan kosong dalam formula yang ini. Okay, so 0 equals to km over vmax, okay, x plus with 1 over vmax. So tukar, kita akan dapat km equals to negative 1 over x. Okay, so x intercept atau pintasan paksi x equivalent to negative 1 over km. Okay, yang ini pindah balik pergi sini, km pindah pergi sini, negative 1 over km. So x sama dengan negative 1 over km, ataupun pintasan paksi x sama dengan negative 1 over km. Ingat lagi, belajar algebra. Ini pindah pergi sebelah, ini tarik pergi bawah sini. Okay, now untuk kita mencari vmax pula, okay, kita mengandaikan 1 over substrate concentration sama dengan kosong, atau pintasan untuk kita mencari yang ini, pintasan pada paksi y, kita mengandaikan x ialah kosong. So kita isi yang ini x sama dengan kosong ke dalam formula ini, which is yang ini kosong kan. Bila ini kosong, what happens? Kosong times dengan km over vmax, tidaklah kan. Yang tinggal hanyalah 1 over v, which is this is y, sama dengan 1 over vmax. So y sama dengan 1 over vmax. Okay, so kita bawa vmax ni ke atas ini, jadikan dia sebagai tajuk, y ini bawa ke bawah. So vmax sama dengan 1 bagi y. So y intercept ataupun pintasan paksi y yang ini sama dengan 1 over vmax. Now, significance of km and vmax. Kenapa you perlu tahu pasal km dan vmax ini? Alright. So km is the index to measure the affinity of enzyme towards the substrate, like what I mentioned earlier. Okay, and km is inversely proportional to the affinity of the enzyme towards the substrate. Betul kan? km is inversely proportional. Kalau proportional means semakin besar km, semakin besar affinity of substrate dengan enzyme. Tapi terbalik sebenarnya. That's why km is inversely proportional to the affinity of the enzyme. Affinity to the affinity of enzyme towards substrate. STRAT, towards enzyme substrates, right? So enzyme with low or lower Km indicates high affinity of enzyme towards substrate, right? Quick formation of enzyme substrate complex. Now, Km also indicates the efficiency of enzymes to attract substrate and convert substrate to products under fixed conditions like temperature and pH. Okay. Now, when it comes to the Vmax, all right, Vmax is the maximum velocity when a fixed amount of enzyme is mixed with an unlimited amount of substrate under fixed conditions. The fixed condition would be optimum temperature and optimum pH. And then Vmax is directly proportional to enzyme concentration when other factors are kept constant. Okay, and Vmax shows the maximum turnover number of an enzyme. Okay, meaning to say the number of substrate converted into products by enzyme per minute in a fixed condition. Right, so that's it about Michaelis Menten. Okay, see you in the next video. Bye.